So the next speaker is Rebecca Barnstaple from York University. She's a PhD student working with Dr. DeSouza and is going to deliver an interesting talk about dancing and music. If you are into art, that is a talk that you have to listen to that. And her talk today is about multi-network visuomotor training to SYNTH-MUSIC investigate with mobile EEG. Thank you, Rebecca, and we are looking forward to your talk.
Great. Okay, can you see me and hear me?
Yes, we can see your screen.
Awesome. Okay, thank you very much. Thanks for the introduction. It was really nice to follow the talk beforehand because I'm also looking at motor learning in a more naturalistic environment, also with applications for neurorehab. So I'm going to try to very succinctly go over a project that we did last year in Berlin that was specifically looking at motor learning associated with dance that we investigated by having people learn a brief 30-second choreography. And we actually used mobile EEG, so we had a live feed while people were learning. I'm just going to very quickly, you can see the live feed coming in, and you can see what we saw from the control room up in the top corner. I'll talk more about that. But so we have people moving through space learning a 30-second choreography. And this is part of work that I do with a couple different groups that are interested on the neurobiological effects of dance. So I'm going to give you a little bit of background and context for this study, a little bit of description of what we do, and then hopefully have some time to maybe answer some questions or have some further discussion. So a few years ago, people in the lab that I work with at York University did a study with expert dancers looking at learning while they were acquiring the choreography for a dance. The main finding from this that was interesting and that we were building on is people were scanned at several points, 4 points, before they learned, at 1 week of learning, 7 weeks, and then at 34 weeks when they knew the sequence to the point that they were performing it regularly. And there was a very clear curve in learning from specifically an activation of SMA. So at 7 weeks, we see the bold signal from SMA is very, very strong. And at 34 weeks, it drops out. So this is suggestive that there's some kind of network reorganization or there's some kind of plasticity going on that has to do with the learning of a motor sequence. With that same group, we've been collecting data on people with Parkinson's who have been dancing regularly at National Ballet School. They come and they take a 1 hour course, a 1 hour class. And one of the consistent findings we have looking at that group, and this is EEG data, is that there's a clear bump in alpha power over frontal areas after class. And this bump is even more pronounced in the people with Parkinson's. So this is very kind of sparse and simple data. This is collected with an emotive cap, just 14 channels, but it was a very clear and consistent result. And we were wondering if this bump in alpha power might be associated with the learning, and if that learning is really driving the process of network reorganization that might be contributing to some of the other benefits that we see. So I went to Berlin to a lab there that had the capacity to do mobile imaging because, well, as you know, dance happens in space. And I thought that it's important that we can investigate what is happening while people are learning in space in a real environment. There's a lot of research emerging suggesting that dance is neuroprotective and neurorehabilitative, but a lot of that research is either happening in a pre-post testing setup or using fMRI or something so that people cannot move and they're responding to stimuli like video, or in the case of the first study I told you about, they are imagining, remembering the steps of a dance that they have learned, but they're not moving in space. So the study design and hypotheses that I'm going to tell you about is published this summer in an article in European Journal of Neuroscience. And if you're interested, please read it. Let me know if you want to talk about anything in there. I'd be happy to. So our hypotheses, we had a whole bunch of them. as you realize, probably dance is incredibly complex. So we're not looking at one set of movements. It's using all of the body. Dance is also spatially oriented and temporally constrained. Often that temporal constraint is coming in the form of music, and the movement with the music can also have to do with expression. It can have emotional content. So we were trying to really delimit things as much as possible in order to get some nice clean data. So we really tried to cut it back to specifically motor learning through creating very brief 30-second choreographies that were very simple in many ways. Also, that was to do with the equipment constraints and trying to limit the amount of jitter that we were getting. And we also used synth-generated music. So it was music that no one had heard before. It had no emotional connotations that people would have overtly, and we actually had participants rate it pre and post for their affective response. Most people rated it very low the first time they heard it, and interestingly, it went up afterwards. And if there's time, I might talk about that towards the end. So we wanted to look at how motor learning associated with dance affects brain dynamics at rest, as we saw in previous alpha studies, or moving through space. We wanted to look for evidence of short-term plasticity. There's emerging evidence of long-term plasticity associated with dance. Can we see some seed for that in a 1-hour setup? We wanted to look at the difference between watching, doing, learning, visualizing, and performing, and also how is it different to watch a person moving live as opposed to watching a video stimuli. And then I have a couple of pet questions for me, because I'm coming to you from the dance department, is can dance create an environment like VR? So this lab that we're in often uses virtual reality to create their setup. We wanted to look at, we choreographed the parameters of the study. So where the person went, what they had to do, that was all part of the choreography. And I also was very interested in what does it mean to be dancing? So phenomenologically, what was the experience like for people? Here's our setup. These are the different stages. So we did collect resting state pre and post. We also had people walk a predetermined path through the space that they would be naive to on their first trial. And then there were 2 subsequent trials where they were learning this path. And this also functioned as a bit of a warm-up. Then we did a more physical warm-up, moving through different body parts and really getting the person moving. The subject then watched a video. They watched a video of a 30-second choreography they learned, as well as one they did not learn, although they did not know which is which. They then watched the teacher, that was me, perform the choreography that they would learn 6 times. They then did it with me, and they had as many trials as it took to reach a criteria of 80% accuracy, rated by an independent rater. Interestingly, that we really saw a difference in participants, whether they had dance experience or not, as to how long it took them. Once they reached that criteria, they imagined performing the dance 6 times, then they performed it 6 times, and then once again on the way out, they watched the videos again, the one they had learned, the one they did not. Of course, now they recognize the one they learned. They did the spacewalk again, and then we collected a resting state again at the end. So quickly, here is what we did. 30 seconds. Not sure how well you can see that. I tried to maximize for video sharing, but you can see the person, this is about 6 learning trials. So you can see they're still making a slight mistake and correction, and then they're going on, but you can also see all the equipment they're wearing. So just to give you a sense of what it was, this is the motion capture data. I'm at the front, the subject's at the back. So we have a lot of data to analyze here. And we have not even really begun to really dive into it. So I'm just going to share a couple of things right off the top that we were able to grab. So one thing, as I mentioned, is that there was a really clear differentiation between expert and novice learners. Novice learners took closer to about 17 trials to be able to accomplish the choreography, and experts took a maximum of 8. And I think that the lowest that we had is that someone actually was able to do it within 2 trials. So obviously experts are mobilizing different skills in order to be able to execute this quickly. And just very briefly, also, this is like just grabbing one of our independent components. We still have a lot of cleaning to do on this data. There are a lot of motion artifacts, but we were able to get a sense that I think we've got some signal coming from somewhere near SMA. We're going to have to do a source localization to try to really dig in and see that better. But we're excited that we have data that we can actually look at, because one of the ideas behind this experiment was also a proof of concept. Is it possible to collect mobile imaging data while people are dancing? So with that, I want to say thank you very much. Thanks for listening. Obviously, I don't do this alone. I do a lot of this work with Joe DeSouza's lab at York, and this study specifically was done with Klaus Graumann's lab, BeMoBIL in Berlin. I'm from York University and funded by SSHRC and MyTax, and these are some of the other people that we collaborate with on some of our other work. Ta-da.
Thank you so much. That was amazing talk and so fascinating. And I'm pretty sure that's not easy to have a dance with a backpack here. Amazing.
Yeah.
So,
it's true.
Chelsea asked that was that any cadence, like what was the cadence of the music for the video that you showed, I guess, or the experiment that you had?
I have to double check, but it was, I matched all of the music, and it was like a pretty standard, like what you would find listening to most popular music. I don't remember exactly the BPM, but I picked something that was pretty standard. And it didn't have a really clear, we kept the rhythmic part, like it didn't have a drum, like we kind of kept that a bit washy, also to make it more about learning the motor pattern rather than really driving it with the rhythm. But of course, it does have a rhythm.
I believe that there are a bunch of data that you are going to process, but does it like change the whole pattern? Like if you have the higher or lower rhythm here?
With the music, you mean?
Yes.
Yeah, we kept the music the same. So we don't have a comparison. We don't have a different type to compare it to. So both of the music stimuli were matched. So I can't answer that specific question, but that is something that would definitely be interesting to look into. There's tons of follow-up that we would like to do, including going back and getting a bit more data on experts and novices so we could really split and do a comparison. And we're very interested in looking at what kind of networks are involved for the experts while they're watching the video stimuli at the beginning, because it seems like they're already learning. Whereas the novices, it was clear they didn't quite know what they were looking at that point.
There was a question by Kelvin Jones that he asked that when participants were imaging the dance, did you play the music for a template alignment?
Yes, we did. Yes, we tried to make it so that we'll be able to look at the imaging, like with the imagination, exactly the same and match it to when they are learning and when they're moving through space. And I'm super excited about that data because it's going to be one of the first like really real-time, real space controls we have of, you know, really, is it the same to be imagining something as it is to be doing it? We're going to have to clean out some of the motor artifacts, but I'm hoping there might even be a couple of areas that we can do a direct comparison, really moment by moment for those 30-second bins.
That was great. Thank you so much, Rebecca. I'm pretty sure that there are so much interesting results coming up, and we are very excited to hear back again. Thank you so much. So before further ado, I'm going to introduce